Hi, this is Bill Brower for Inside Edge Systems Easy Language Learning by Example Tutorials for TradeStation. This is a special video supplementing the preliminary videos which covered exercises 1.01 through 1.10. This information is about inputs and variables, and will show you some additional information that may not have been clear or presented in the initial 10 preliminary videos. I want to start off inside the TradeStation development environment and work with LBE X average diff, which came from exercise 1.03. You will notice that this has both an inputs declaration with two inputs, MA length 1 and MA length 2, and 3 variables. Now, one way you can look at this is to look at it from the code side and examine their behavior inside the code. But when it comes to inputs and variables, it is a little difficult to see the advantage and the disadvantage of using inputs versus vars. But on the other hand, if you go to the charting side, you can see the benefits and the features a little better. So here we have the LBE XAV diff plotted in a subgraph. And if I go ahead and look at from the menu, I click on Format, Analysis, Techniques, and look at the XAV diff, I notice that there are two numbers right here. They're called input values. And if I select Format, I can actually go and see what those inputs are called, MA1 LEN and MA2 LEN, and I can actually change them. They're set now for 10 and 20, but I might want to see 5 and 10. And notice how this changes dramatically the plot. Or I might want to say, if I double click on it, I can come directly to the inputs. And I might want to say, well, I really want to see, how about 25 for the shorter length and 50 for the longer length. And now we see a much smoother plot. So what you do not see when you go to Format and Analysis Technique is the variables. You only see the inputs. So inputs can be changed from a chart window or from a radar screen window. The variables inside your analysis technique cannot be changed at all. Now there are some advantages to that, in that the user is not confused by a list of variables that may have no impact on what he is trying to accomplish, he or she is trying to accomplish. But there are some other advantages too. Let's say you're providing an indicator to someone, and you know that the inputs should be called, after doing some testing, the inputs should be defined to 9 and 14. You can hard code these as 9 and 14 as long as you change the inputs to a vars. So if I go vars, I now have changed those inputs to variables. If I verify the code verifies down here, saved and verified. It behaves exactly the same way with one exception. If I now double click on the code, there are no inputs available. So my user cannot make any changes to the code or from a charting window. If in addition we wanted to protect the code and lock it up so that he couldn't even have access to the code, then he would be strictly using the inputs that we have provided in hard coded. So now that's one advantage of using vars over inputs. You can hard code things so users don't have access to it. I'm going to change this back to inputs because I would like to have the inputs available. Now, there's another reason to use variables instead of the name of the function they are calling. This is a function called average. You'll notice that right now there is the moving average length 1 is associated with MA val 1, and moving average val 2 is associated with MA length 2. So each of these is computed, each moving average is computed one time on every single bar of the chart, with one small exception, which we will eventually learn. But there are other lines of code in this indicator. This line of code, for instance, and this line of code are not evaluated every single bar of the chart. They are only evaluated once on the very first bar of the chart. There's no need to look at what the setting is for MA length on more than one bar of the chart because it's always set to the same number. However, MA val 2, MA val 1 on the var side and MA val 2 and MA diff is a declaration. So the declarations do not need to be run on every single bar of the chart. There's no need to reset MA val 1 to 0 on every single bar of the chart. It's a common misunderstanding or misconception that somehow these variables are reset at the beginning of every bar of the chart. That does not happen. If you want your MA val 1 to be reset to 0 or some other number, you would have to actually do that. And you could do that by saying something along the lines of MA val 1 equals 0. Now this line of code would indeed run on every single bar of the chart and would reset the variable MA val 1 to 0 before it calculates a new value. Now, I don't want that, and I don't need that, so I'm going to erase it. But you will notice, I'm going to verify my code. The code also includes a calculation down here, MA diff. And I might want to know something about whether or not MA val 1 is above MA val 2 or below it. And if it is, I might want to change the color. So let's go and change the color to red if the diff is negative, and to green if it's positive. And so we would have something like this. If I could actually, I could make this Control C, I'm going to copy it, Control V. If that is greater than 0, then, and I'm going to say my color equals green, and this is the way I like to see it formatted. Else color equals red. Now, one of the things you will notice is that color is not really specified here, and we would have to declare that as a variable. The colors red and green are actually numbers. And if you right click on here, you can go and look at the definition of red and green. And over here, this is the numbers corresponding to numeric values. So green, under the legacy color value, those are the 16 different colors which are available. Green is a 4. And red is a 6 here. Well, by definition, unless you specify otherwise, TradeStation uses the RGB value, which allows you a much greater access to colors. And there are way more colors. There's millions of colors available, and many of them have names. But we only want to use the legacy color value. So because of that, we have to put in this little odd piece of code. It looks funny. And we're going to say legacy color value, and it turns gray if you typed it properly, equals true. Okay, so now that tells the piece of code to use the 16 color scheme as opposed to the RGB color scheme. And we know that green is a 4 and red is a 6. And we can actually come here and tell it to change the color by putting a color out here. And I'm going to verify the code, and if I've done it correctly, it will pop up without an error message. It does say I haven't defined that variable, so I need to define that. And we know it's a number, so it's I'm going to use a 0. Now I verify it, and it says saved and verified. If I've done this properly, I now have 2 colors on my chart. One of the things you may notice is that what happens if MADIF is equal to 0? Then what happens? Well, it gets colored red, and that's just the way it is. If I want a third color, I have another else condition. Else, if it equals 0, then the color is dark gray or something. But I'm going to leave this like this. Now, you'll notice that I could have gotten rid of this MADIF here altogether. I really don't need this in here. So I'm going to delete this variable. And I'm going to delete this because it's deleted. I now have this. This is gone. So instead, I don't have an MADIF. I now want MAVal minus MAVal1 minus MAVal2. So now this does the exact same thing, except that I don't have it down here. So I have to repeat this computation again down here. Anytime you perform a computation more than once, you're putting additional burden on your processor. It has to actually make this computation. It has to make this subtraction. So by computing the MADIF once and then using it to make a comparison at this location and in a plot statement down here, I've eliminated one additional computation per bar on the chart. So in this case, it's no big deal because these are already saved as variables up here. So if I verify this code, it should say saved and verified, and it does. And you'll notice that the plot is identical. So not a big deal. But where this can become a big deal is if I extend this concept even further, and you will see this done by people who are novices. They don't bother to use variables at this location. So instead, we could just simply use the user function. So I'm going to comment out my code here, and I'm going to take my MAVal1, which is this, and I'm going to stick it in at this location. And I also see it down here in this location. And I'm going to take my average here, and I'm going to stick it in at this location. And I'm going to stick it in at this location down here. And that's very clever because I just got rid of these 2 variables. Believe it or not, people actually program this way, and it works. So if I verify the code, it works. Saved and verified, and there it is. How lovely. Except I now have to compute this moving average here and I have to compute it a second time down here. Now, an average is simple enough. I just simply, in this case, its moving average length is 9. So I take the last 9 bars, I add them up, and I divide by 9. But that's, if I repeat that computation a second time on every single bar of the chart, that can actually begin to slow down the processing quite a bit. The average is actually rather quick, and they even have a faster average computation. But even so, you don't want to do that. The reason you want to use variables is because it speeds up the computation. If I have a piece of code that is 1,000 lines long and I compute the average every single time it is needed, the actual computation may grind to a halt. You don't want to do that. Even simple computations are better off left in an assignment to a variable. So I'm going to back this all out, Control Z, and I'm going to get back to where I was. Here is where I was before I changed. So I'm still left with MAVAL1 and MAVAL2, and that is a computation. Theoretically, I would not want to compute this twice. This and this are identical. It should only be computed once, and that would be the reason why I would want to have an MA diff computation. Let's talk about the value variables. TradeStation provides variables value 1 or value 0 through value 99. I could actually take a shortcut here and get rid of these variables here like this and simply say value 1 equals value 2 equals, and I have to substitute them down here. Here's value 1, value 1, value 2, value 2, and I verify my code, and lovely. It works. Except for one thing. With 6 lines of code, or 8, however many I have here, it's not a big deal. But if you get in the habit of using value 1 and value 2, and then suddenly you need value 3, and then more values, and next thing you're using value 56, and value 57 is the difference between value 54 and value 53. If such and such a condition is true, and value 53 is dependent upon 6 other values, you will get completely lost. So, the only time you should ever use value 1 or value 2 is for a placeholder computation, which I will explain that in a minute. It can be used as a counter sometimes. But again, if you use this as a counter in a loop counter, which I have done frequently over the years, and there are times I actually regret it as the code gets more and more complicated. You have loops inside of loops, and it's very difficult to understand the code if you're using value. So in general, I would say do not use value 1 and value 2 if you can create a custom variable to more accurately describe what you're trying to do. So if this is an average, say average or MAVAL 1, and then use that in place of the value. So here is value 1, and this is value 1, and this is value 1. Then when I go and I look at my code the next day or 6 months later, I look and I say, oh, this is value 1. That's an MA moving average value. Value 2, I don't know what that is. I have to scroll back up in my code and I see, oh, value 2, oh, it's assigned to a moving average. Maintaining your code can be very difficult if you use values for your variable declaration. So don't do that. I'm going to go back to MA val 2. And now once I get this code straightened out, I'm going to explain placeholders. Okay, so even in this form, it's not ideal. I perform the same computation twice, once here, once here. MADIF should be computed here and then used at this location. Now, what's a placeholder code? A placeholder code is generally used in case a user function doesn't return anything meaningful. And a function like average actually does return something meaningful. It performs a computation, but when you get to be more advanced, you will be able to have code which returns a string of variable values through the inputs location. And what you can do is simply put a placeholder a variable at the to call it, and it doesn't do anything. It's always true, or it's always equal to 0. So for instance, I wrote a piece of code recently, and I'm going to pull it up. This is from an exercise that you will be getting to in the second quarter. Okay, so it's File, Open, and I want to go to my user functions. I'm going to sort them. By the way, if your list of Easylanguage documents looks like this, you can come to this information display icon, click on it, and it gives you detailed information about all of your different functions and indicators. And the reason that's helpful is because you can then quickly sort by going to the column header and clicking on it. And for instance, if I wanted to see all of the restricted or protected ones, I could do that, or the unverified ones, I could go there. In this case, I just want to know, I want to find a recent piece of code I've created. So here is Candle Synthetic. Now, I was telling you that through the inputs, I can pass values back to my calling routine. And you will notice that these are kind of odd looking inputs. They've got an O underscore in front of each one of these. That is because all of the information that this user function passes back to the calling routine passes it back through the inputs. The actual returned value of this user function will always be -1. It does not return a value that's useful in the conventional way that other user functions return values. They pass values back through the inputs. This is a more advanced technique. You will be able to see this later on. But just keep this in mind, that the reason that you may want to use value 1 is if I'm calling this function, LBE, Candle Synthetic, it has no meaning other than through the inputs. Here, average, if I click on the average function, I can see right here that the average does have a meaning and a value that can change over time. There's a computation assigned to that average. That's not true with some functions. This one is completely static. It always returns the value -1. The only way you can get any information out of this function is through the list of inputs. Okay, so bottom line, do not use value 1 or any of the predefined variables unless you have an extremely short piece of code, or it's a real quickie. You just don't want to bother with it, defining it. The advantage of the predefined variables is you don't have to have a var statement to declare them. So yes, you save a line of code by using value 1 or value 2 at these locations. This line doesn't have to be used at that in this piece of code if I use value 1 and value 2, but it makes the code hard to support, hard to read, and ultimately, if you get in that habit, you're going to regret it. Take the time, document your code so that you can read it. MAVAL, I know that's a moving average. I want to spend a minute or two about condition variables. They're similar in their usage to the built-in predefined value variables, except they are Boolean, true, false. So here I have a Boolean statement. This statement is true or false. I'm going to take that Boolean statement, Control X, I'm going to delete it, and replace it with a condition statement. Condition 1 is the Boolean statement. And then I'm going to reuse condition 1. Whoops, Control V. I didn't mean to do that. Control V again. And if I verify my code, it verifies quite nicely and it plots. But what this does is saying condition 1 is true if whatever is on the right side is true. Condition 1 is false if whatever is on the right side is false. You can see that although it works, condition 1 isn't very descriptive. So I'm saying that you should, again, not use the built-in condition variables, the predefined variables, unless it's completely obvious. You have 3 lines of code or 5 lines of code and it's a quickie. You don't want to use it for any kind of code you're serious about. It's hard to maintain. It's hard to read. So I come back up here and I put in is MA1 over MA2, and that is a custom conditional false variable. I'm going to copy that. I'm going to paste it in here and stick it in here. So now I have a conditional variable which I can read. It tells me what it does. If the MA1 is over the MA2, then the color is green. Otherwise, the color is red. So what I want you to learn with conditional variables is they can be used, but you generally don't want to use them unless you have an extremely simple piece of code. And I would urge you just not to use them at all, because you tend to get in the habit. You'll have a simple piece of code and it looks promising. You'll extend it. It still looks promising. You want to tweak it. You want to test it. Still looks promising. You want to hold on to it. You come back to it later on and you've got all these condition variables and value variables. You don't have any idea what they're doing. It's confusing. It's hard to maintain. Just stay away from them. Use descriptive names for your variables and you're going to be a lot better off. Now I want to say a few words about functions. Functions are places where you can condense the computational engine for your code and maintain it and use it in multiple pieces of code. So if I come up with a custom computation, like for instance this candle synthetic piece of code, it's a function. Here you can see fx, that stands for function. This is an average function. If it's red, it means it's protected read only. I can't modify it. Over here you'll notice that the line through the little bars shows that this is an indicator. If it was a strategy, you would see little arrows like trading long and short. Here's this LBE custom synthetic function is a place I can maintain and compute something and use this computation without having to repeat it in the body of my code. So if I were to stick all this code over here in an indicator, it might work. I could make it work, except that if I then write a strategy that also uses that very same concept, now I have the code in two different places. I will have this one piece of code called LBE synthetic, or actually the code for that stuck in an indicator and running in another location called the strategy. And so if I come and I make a change in the indicator, I have to remember to go back and make a change in the strategy. All that can be fixed quite easily if I just use a user function, keep the code down in a user function, and then call it in the same way that I called this moving average. This moving average can be used in 100 or 1,000 or 10,000 different pieces of code, and it's always going to be maintained in that one location. If I make a change to that one location, it changes all the code throughout the entire library in strategies, systems, show me's, indicators, paint bars, so for ease of use and maintenance and serviceability of your code, it's helpful to use functions. I also want to make just a general comment about the if, then, else statements like this here. The reason you want to use if, then, else statements is to give you the ability to filter out data. In this case, I'm using it to filter out those moving averages that are moving average diffs that are greater than 0 from those that are not. They would be less than or equal to 0. Without an if, then, or else statement, I would have no way of changing the color from green to red or back again. So this is the purpose of the if, then, else statement. It gives you the ability to filter out your data. When it comes to math, I would suggest that if you are comfortable with math, go ahead and pay attention to how these user functions are created, how the math in them works, because you can use them, but it helps if you understand the math behind them. It helps to understand why something is what it is and why it should work. So for instance, the momentum function. Do you know what the momentum function does? Well, for one thing, most of the algorithms in TradeStation or in any trading platform were put together by people who were not engineers, and therefore they labeled things in a fanciful way and oftentimes a meaningless way. So oftentimes the names don't bear any resemblance to what they're actually doing. If I click on momentum, which is a term from physics, I can right-click on it and look at and see what it's actually doing. And lo and behold, it's nothing more than the price on the current bar minus some previous price. So I can find the momentum by looking at the price on this green dot here and go back 5 bars, 1, 2, 3, 4, 5, and the momentum will be the difference between this dot here and this dot here. So I would encourage you to look at the math behind these functions. They're not frequently, a lot of them are not particularly complicated. And you should understand what they're doing and why. Otherwise, you may misinterpret what your code is doing or should be doing. So that about wraps it up with information about inputs and variables. This is Bill Brower for Inside Edge Systems, Easy Language Learning by Example, tutorials for TradeStation. I hope you learned something. Thanks for listening.